Hi and welcome to this tutorial on HeuristicLab Hive. In this video we will have a look at how HeuristicLab can be used to create and run experiments with HeuristicLab Hive. An experiment is a collection of algorithms that have different parameterizations and may also work on different problems. Experiments can either be executed on a computer locally or sent to HeuristicLab Hive for distributed and parallel calculation. HeuristicLab Hive is a distributed computing infrastructure that consists of the Hive server and multiple slaves. The server is a web service that runs on Windows operating systems. It is responsible for storing and distributing jobs to slaves, which are then in charge of executing the jobs and sending the results back to the server. Depending on the number of slaves that you have at your disposal, this can dramatically speed up execution times. But let's first start with the experiment. I have just opened HeuristicLab and I will now use the GA-TSB sample for creating an experiment. If you click on Edit, Create Experiment, you are greeted with a new and improved dialog. On the left side we can configure parameter variations for the algorithm. For example, I want to try out different mutation operators. Therefore I click on the Mutator checkbox and mark the ones that I want to use. I also want to examine different population sizes, so I click on the population size and get automatically a variation with 3 different sizes, in this case 50, 100 and 200. We can now either change the length and configure an additional size, or we can let HeuristicLab do the generation of the variations by clicking the Generate button. For example, I want to run from a population size of 100 up to 1000 with a step size of 100. So I change the minimum to 100 and the maximum to 1000 and click OK. You can see that we now get 10 parameter variations for population size. Note how on the bottom left of the window the variations count changed to 40. The reason for this is that HeuristicLab will generate for every variation of every parameter a new and configured algorithm in the experiment. Besides configuring parameter variations, we can also set repetitions. In this case the default is 10 repetitions for each variation. We could also apply the configured parameter variations to different problem instances. If we switch to the Problem Instance tab, we can select different TSB instances that are shipped with HeuristicLab. If we select for example 2 instances, we can see now that 80 configurations will be generated. But for now 1 problem instance should be sufficient. Let's press the OK button to start the generation process. We can see that a new tab has opened where the generated experiment is shown. For every configuration we have a batch run that will be executed 10 times, and we can also have a look at the different parameters to see if everything went right. You can also see that the names of the algorithms are set to the parameter names and values so that you still have an overview of which algorithm is configured with which values. If you want to run this experiment on your local machine, you can just press the play button. You can see that the icon of the first batch run changes and gets executed. We can also start multiple runs by selecting a batch run and click on play again. This of course works very well for small experiments, but if you think about experiments that contain, for example, 1000 variations, this can take quite a while even if you have a powerful CPU. So to speed things up, we will now use HeuristicLab Hive for running this experiment. I will now click on the Stop button to abort the experiment and open the Hive Job Manager. You need of course a valid user and password for working with Hive. You can configure the user in the menu under Set Username Password. As you can see, I have already entered my credentials. If you want to use Hive, you can either set up your own Hive server and slaves, or you can contact us if you want to start a research collaboration and use our Hive infrastructure. You can find the details and links to the documentation in the description of this video. Okay, so let's continue by starting the Hive Job Manager by clicking in the menu bar under Services Hive on Hive Job Manager. We can see that a new tab opens where you have on the left side a list of Hive jobs and on the right side a few with additional information. As you can see, Hive also supports sharing of experiments between different users. That's why I also see experiments that my colleagues have shared. We will now create a new Hive job by clicking on the Add button. On the details page, the top, we can now define the name of the job. For example, let's call this My GATSP experiment. Under the name we can select resources where we want to compute the experiment. If we click the magnifier button, we can see which compute resources are currently available. For now the heal resource group is okay, so we don't change anything here. And last but not least, we have to get our newly created experiment into the job. While we could add algorithms manually with the add button, we will now simply drag and drop our experiment into this Hive job. So I just switch back to the experiment, click on the view host and drag the experiment back into the Hive Job Manager and drop it into the tasks view. The Hive Job Manager now splits up the experiment into separate tasks for each configuration and repetition. These can be calculated independently and therefore will be sent to different slaves. The slaves in Hive perform the execution and then send the results back to the server, from which the Hive Job Manager fetches the results. On the left side, we have now the experiment with every variation and repetition converted into an own separate task. And on the right side of the window, you can now, for example, configure the priority of the task. In this way, you can tell Hive if this is an important task or a low priority, and the Hive server then decides when it gets calculated. Okay, let's upload the experiment to Hive. Just click on play and you can see that the upload starts. Let's fast forward a little bit so that you can have a look at what is happening while the experiment is running. If refresh automatically is checked, we get real-time status information about the job and already finished runs are fetched from the server. We can see in the execution history tab for every task if it is currently waiting, executing or already finished. If there are already finished tasks, we can also have a look at them in the runs view and use the standard HeuristicLab analysis tools to have a look at them. Let's fast forward again and examine a finished job. Now that we have all the results, the Show Modify Optimizer button is enabled. If we click this button, the original experiment with the results is shown. Let's just quickly have a look at them with HeuristicLab's analysis tools. In the Runs tab, I will now click on the Analyze Runs button. Here we see different tools that we can use to analyze and compare our results. Let's select the bubble chart and have a look at the influence of the mutation operator on the quality. Therefore I select the mutator on the x-axis and on the y-axis best quality. We can see how good or bad a mutation operator worked. Of course, we also vary its population size, so this is an influence that we should also have a look at. Therefore, to get a better overview, I will now color the bubbles by mutator and switch the x-axis to population size. Now we have a good overview of the different configurations and their influences and can draw our conclusions. So thanks for watching, and if you are interested in more information about HeuristicLab Hive, please have a look at the documentation linked in the description of this video.